Hello everyone. We are going to have a brief introduction of SonarQube. SonarQube is a static application security testing tool. What it means is that it helps a software engineer to identify any discrepancies in the source code according to the best practices and coding standards, as well as it helps the software engineer to identify any security vulnerabilities such as OWASP top 10. Let's just straight dive into an example. Here is an example of a non-compliant code detected by SonarQube, where we can see SonarQube identifies a for loop where it identifies a break statement should be removed, and it display a suggestion for the compliant solution because it thinks that in the presence of the break statement there is no point and no reason to have the iteration, because iteration will not work at all. Due to the same reason, SonarQube suggests to remove the return statement in the next another for loop construct. SonarQube supports many different languages including Java, C++, JavaScript, Python, and many more on different operating systems. Why we use SonarQube? Once again, we need to be assured that our software is free from security vulnerabilities and it is written according to the best practices and coding standards, leading to have a higher quality of source code. It is important to remember that any flaw reported by SonarQube does not necessarily has to be fixed and refactored as suggested, because there could be false positives. And of course, SonarQube can be used for educational and learning point of view because it helps us as software engineers to stay abreast of the best practices and coding standards. What are the main components of SonarQube? SonarQube Server Web Portal and Sonar Scanner. Sonar Scanner is the basic scanning and analysis component that performs the scanning on the source code and reports the identified flaws to the SonarQube Server Web Portal. Here we can see in this little picture of web portal that when the flaws are displayed on the web portal, then they are categorized either as bugs or vulnerabilities or hotspot reviewed and so on. It is important to remember that before running the Sonar Scanner, we must have to have SonarQube server up and running. So how the scanning works? Scanning can be manual or automated. In manual scanning, we have to have a SonarQube server locally set up and running, and then we have to have a Sonar Scanner locally available that we can trigger from the command prompt. In case of automated scanning, when a software engineer commits a source code change to the Git repository branch through CI/CD pipeline, then there are Jenkins jobs already configured, which triggers the Sonar Scanner that performs the scanning on the code, and then the identified vulnerabilities or flaws are reported to the SonarQube Server Web Portal. When the flaws are reported to the SonarQube Server Web Portal, they are categorized into 4 different categories. And other than these 4 different categories, there are 2 more statistics are displayed on the SonarQube Server Web Portal. The flaws are categorized either into bugs. Bugs are those errors that SonarQube believes that must be fixed. Vulnerabilities and hotspot reviewed are the security loopholes identified in the source code. There is a slight difference between vulnerabilities and hotspot reviewed that I'm going to discuss in the next slide. Code smells are those small improvement suggestions in the source code that SonarQube understands needs to be refactored from the maintainability point of view, because these are confusing or complex code that has the potential to be simplified. Further, SonarQube gives us the statistics on the percentage of code that has been tested and the percentage of duplicate code found. The difference between vulnerability and hotspot reviewed is that vulnerability are those flaws that SonarQube believes must be fixed, must need to be refactored. Hotspot reviewed are those security loopholes in the source code that SonarQube understands that should be highlighted, and then let the software engineer review it, and then if he decides, then it can be either ignored or refactored as suggested. Here is one simple example of a non-compliant code identified by the SonarQube, and it is categorized as code smell. It simply suggests that the functional interfaces should not be marked as sealed in the Java code. This is another non-compliant code identified by SonarQube, and it is categorized as vulnerability, and it says that HTTP request redirection should not be open to forging attacks, and the suggested refactored compliant solution emphasizes to perform input validation on the URL before redirection. So our main conclusion is that we need to have a source code that is robust, free from security vulnerabilities, and according to the best practices. Thanks.